we simply introduce myself. I'm Gil, fourth time here. I usually work all different kinds of facets of development, like product and development and testing, and some business development, all kinds of things that I'm going to reference in this talk. And this talk is about how we basically shoot ourselves in the foot, or collectively in our feet, by making things more complex than they used to, they need to be. I'm also the author of Everyday Unit Testing, which you can download, and if you're interested in unit testing, but this talk is not about this. And for the people who haven't tweeted yet today, this is your chance to say this is the best talk ever. Please do it at the beginning, because later you'll change your mind. Yeah, so this is a serious talk. We'll start with a quote by John Gall. It says, "A complex system that works is invariably found to have evolved from a simple system that works." So we had something that worked, and it became more complex. So how does this work? Why do we do it? So much like Steve here, you remember him from the 70s, we wanted something better, stronger, faster. So we wanted something that gives more features or more customizations to the customer. We wanted it to be more efficient. We wanted it stronger, that it can scale. Now the problem is that when we had this as a startup, or this product, or this project, it was okay, it was manageable, sort of. But then we started putting all these things on it, and it seems like we're moving slower and slower, much like Steve here, remember? When he moved faster, things became slower. And at some point, it's like we're frozen. And it gets to the point where we say, let it go. We need to rewrite this thing from the top. We need a new process installed. We need Windows 98. No, we don't. We need to replace the platform. And the problem is that it's very painful to do this. So what we're looking for is really to avoid this. Sorry? If it's not funny, use the green stem. Okay. Yeah. So we said this is painful. We'd like to avoid this. And we'd like to avoid this by being in control. Now, control is a very funny thing. Here's another quote. "Control is an illusion, you infantile maniac. Nobody knows what's going to happen next, not on a freeway, not on an airplane, not inside our own bodies, and certainly not on the racetrack with 40 other infantile egomaniacs." Who knows where this is from? It's from Days of Thunder, starring this infantile maniac. And it's true, right? Control is an illusion. We can't really control. Imagine you're a race driver. You have all kind of mess all around you, and you think you're in control in your little box. But you don't, because the car itself is very complex. Anything and everything can go wrong in a minute. So we're still looking for control, though. Why is that? It seemed to me that, and this is a theory, I can't really prove it, I can perform an experiment though, that when things are simple, they're easier to control, and I think they're easier to control because of the short feedback loop. When things are very small, we can poke them around, see what comes out, and respond. In complex systems, like every Canadian major will tell you, it's not the case. You can poke all kinds of things around, and what you see you may even interpret as the wrong thing and respond in a bad way. I think this is where we get the feeling of we can control simple stuff. So here is an example. This is the cone of uncertainty. Who knows this thing from like 30, 40 years ago? Yeah. Get ready for a surprise. Okay. So this is the cone of uncertainty by Steve McConnell. I think it's coming up to its 40th birthday or something like that. And it is used to describe what we know about a project. And at the beginning of the project, we don't know a lot. And this is painted here. It's drawn by the variance of what we don't know about the project. So everything can change. As we move forward towards the end of the project, this variance narrows. We learn more by building the project. Makes sense, right? It's very simple. Ah, there's the trap. It's very simple, but it's not true. What happens really in real life? We build it, we learn a bit, and then we find out stuff that we didn't even know exists. So it's back here. So it's like a jagged thing. And soon enough, we kind of swept into it because it's not really converging. It's like a whole mess of complexity around us, which can be very lethal because, like every vortex you've seen, it can be full of sharks. And this is a problem, okay? They tell us to embrace change. It's agile is all about, right? Acknowledging that change exists, but this happens also. And it's painful sometimes. So complexity, this is the real Batman, by the way. Our lives are really complex. And every time well, if I had told you that you can't control your life, what would you do? You'd probably hit me, right? You can't stand the feeling of not being in control. We're looking for cures. Like this one. Who knows what this is? Waterfall! Winston Roy's masterpiece. And I don't think he named it Waterfall, by the way, but he painted it very nicely. You can actually see the water falling from one stage to stage. Very simple to explain, right? And it also has a very strong basis in manufacturing, because that's how we do it in engineering. So that's a cure for everything, right? Of course, if you read the small print, I believe in this concept, but the implementation described above is risky and invites failure. It's from the original paper. Even the creator of Waterfall saw what's going to come. So, simple to explain, very hard to implement. So we're looking for the best next thing. Probably seen this before, hopefully, if you're in the right conference. Of course, it makes sense. Individuals' interactions are, of course, more important than processes and working software. Of course, it's much important than bags of documentation. It's very simple to understand, but hard to implement. So we're still looking for the next best thing. Maybe this one will work. What is this? Scrum. Very simple to understand. It fits in one slide. Like you have 3 artifacts, 3 roles, a nice box here. Nice round number. This is the original with 30 days. So very simple to explain. We find that it's very hard to implement. I think you see there's a pattern here, right? So what comes next? Yeah. This broke the pattern. But we're not going to talk about this. It's not easy to explain, and I don't even know if it works. It will. Talk to the people actually doing this. I don't do it, so maybe it will work for them. Anyway, why are we going through this over and over again? We're looking for some kind of a rule book. This rule book will tell us in a very complex environment what to do. Sometimes the rules don't apply to the context. This is an example. If there are any Americans here, please forgive me, but I really like this example. So this is from 2013, I think. Yeah, January 1st, 2013. It's New Year's Eve. There's 2 sessions of fireworks planned for this evening. There was a shooting in the first one. Okay, an actual shooting. Police comes in, clears the area. Okay, what does he do? Cancel the second shooting. Okay, it makes sense, right? because the probability of another shooting occurring the same evening, because it's the same venue, same fireworks, no, not the same people, it makes sense that this will work. Because that's what they say in the rule book. This is how you keep risk down. But that's instead, a lot of people who are happy to get there and probably wouldn't get shot got to see fireworks on the TV. So rules don't apply in every context, because we're thinking, yeah, what to do with this? If Jackie Chan has problems. Okay, so we know that this rule book that we're looking for probably isn't there. We still continue to look for it. So what do we do? One of the things that we try to do is reduce complexity. It's not easy. This is a quote by Steve Jobs. Simple can be harder than complex. You have to work hard to get your thinking clean to make it simple, but it's worth it in the end because once you get there, you can move mountains. If anyone can move mountains, well, could have before was Steve Jobs. He was talking about design, but it's also true about everything else we do. It's hard work. The problem is that even this hard work, if we don't do it, it costs us a lot, because what happens when things get complex? Let's see. Who is a developer here? Nice, we'll get back to you later as well. Have you inherited some legacy from others to maintain? Yeah, that's a cost we pay. Do we have project managers or stuff like that? We'll get to you. Projects got big, right? Suddenly you have a lot of work to do, and you need more project managers, which is kind of weird, right? Or even products. Your company, we're all one company. You're working product A, you're working product B. Product A gets released. Sorry, but you did a lousy job. Maybe if you did a great job, it just nobody buys it. And you guys did magnificent jobs, but because everybody heard about the success of product A, nobody's buying yours. It's the halo effect. So things are really out of our control. So I'm going to give you a couple of examples of things that we actually do. I'm going to start with requirements. Who think this is true? That customers don't know what they want? Excellent. Do product owners know what they want? Okay, so keep that in mind. Yeah, requirements are a fine thing. And we try to manage them by reducing simplicity. One of the main things that Agile told us was that if we want to have this big vision we have in our head as product owners to be actually built by developers, we need to feed them in very small batches, like using this template. What happens when we use this template, except from Robin getting kicked? We're oversimplifying, right? The tool itself is very nice. It's simple, it's easy to explain. But then we have all these kind of screens and mockups and behavior and edge cases that are part of the requirement. So what do? More documentation, of course, like it says so in the right part of the Agile Manifesto. So we're adding complexity just by trying to reduce it. So what can we do about it? In the early days of extreme programming, customers actually sat with the developers, or it was the other way around, developers sat with the customers. They didn't write stories. They told stories. They answered questions. And this is what we need to do. So maybe we can't have customers sit in our space, but we kind of arrange the organization in such a way that product owners will be sort of available. Don't make them write stories that you need to read later. We need to actually learn how how to tell a story. We need to prioritize learning. This is already came up in Andreas and Angel's talks. It's probably going to be again later. We need to prioritize learning. And that means there are no requirements. Because show me one project that you did and everybody else that had at least one requirement not ship in V1. Oh, these are not really required. Okay? These are assumptions. We need to learn about will it work, will it not work? So we need to prioritize these things. We need to practice and get better at it. And the main thing about not just presenting and listening and understanding what it means, it's about education. Education of helping the developers, testers, whoever, not the product person, help make them be able to make very good decisions about the product. Because if they understand the business, you'll have, instead of one product owner over 20 people, you'll have 21 product owners, which makes nice discussions and meetings, but instead of that, you can delegate some of the decisions to the team. You get better decisions, better products. It's much simpler like that. But if we're talking about developers, let's talk about these things. I actually tried to find something better, but I couldn't. I don't know, finding things in Google become way more complex. But yeah, so this is a dialogue. I'm guessing from photo viewer, because it says so. It says like this: download has failed, good. Please check USB connection, you idiots. If USB connection is okay, why am I showing you this? Retry and download. If it doesn't, well, I don't know. And I hope no marketing person will see what I wrote here. Photo viewer may be damaged? Nah. And if you need to operate this heavy machinery, no means cancel, and retry means try again, because you don't know English, right? So all the information is there. When I talked about product people delegating business decisions to developers, this is what they're afraid of, right? So yeah, how do you think this happened? I have no idea, it's just theory. I'm thinking it was like error handling, it wasn't written in the requirement or the spec, something was happening. The developer said, okay, I'm going to try this. I'm going to give them all the information they need in order to operate this. This is what happens. So this is one case where developers think maybe a bit bigger out of their fence, but it's not their fault. They're in fault for this thing, the next thing. This is the Wikipedia. You probably can't read it. And the reason you can't read it is because I actually zoomed out. This is the list of programming languages in Wikipedia. I zoomed out, so everything that starts with A, and that was, I apologize, this is 3 weeks ago, it may have changed. So these are the languages starting with A. You can see by the side of the scroller how many languages there are. Oh, there were 3 weeks ago. Okay, so let's do a survey. Who thinks the world needs more than 10 languages? 4 people, 5 people. Okay. Why do you think the world needs more than 10? Who is it? With the 1? Yeah. Diversity. Like everyone, because he's a human being, deserves a language? Why not 2? It's boring. There are no boundaries. We can't contain our creativity, right? So this is what happens, and this I actually wanted to check the number of JavaScript frameworks, but the number will keep rising and rising. So, yeah, this costs us money. Okay, I was telling the SimCorp guys yesterday. I'm not sure if they're here, about APL, which is a very short slice of very customized in programming language, and I'm sure there was a very good basis for this decision to decide we need a new language. But I don't think we'll need more than 30. And like I said, get some people to help you. The APL is not something that you even try to find a developer that knows APL. Okay, you need to train them. And at the end, who knows COBOL? Of course not. They're on their yacht right now. Very rich people. It's very hard to get them. Yeah, costs a lot of money. Here's another thing that costs money. Now, the developers know that the green thing is a comment. The non-developer look at the English words they identify and that say it doesn't look like they're actually multiplying by 4. This costs money. This costs time. And I don't like to be the next developer who get this but without the comments. Because obviously everybody can understand what I actually wrote, right? Every competent developer. So all these cases are about going back to Jurassic Park. Of course, how not? Well, Jeff Goldblum told us this about the scientists at Jurassic Park. I think we can apply them to developers. Developers were so preoccupied whether or not they could, they didn't stop to think if they should. They shouldn't. Okay? They probably could, but they shouldn't. So what can we do about this? Conventions. So not conferences, conventions. Development conventions. So the Ruby on Rails guys, I'm not sure if they coined it, but were very strong supporters of convention over configuration, which means we draw a line, like the A3 line. We draw a line. Everything within this line works. Everything outside the lines may work or may not work. We can't guarantee it. We need that as well. Because if we focus on what happens inside the box, we can create a better software, because we can guarantee what works inside the software, because we're focusing on that and not everything outside and customizing every option for creative people or customers and so on. Code reviews, obviously. Code reviews also help us with conventions. And this is a nice thing to have, it's a must really, but it only works at the team level, because if we're jumping into the enterprise level, group level, most of the people on the team don't know what kind of code is written on the other room. And then we need a police, and we need a cup, code cup, architecture cup. Someone who knows what's going on, that's his job. Mainly, it could be a full-time job, really. He can say, this is how we work now, the culture that Andrea was talking about. And if you're thinking, hey, we have one of those, he's called an architect. He's not. He's one of the problem, okay? These guys have took a while since they actually wrote code, so we don't let them actually decide how we write code. Simple design principles. There's Kent Beck's 4 rules of simple design. Look it up. They're very simple and very easy to implement, though. Yagni is you ain't gonna need it. It's most of the code that we write. Okay? Most of the code we don't write because we need it. It's because we think we'll need it. What happens is that this code becomes part of the code base, and therefore we'll have bugs in it, and we'll work on bugs that even not related to what we actually need to work on. Again, complicating stuff. Finally, education, because yeah, you can't do this. You can't expect people just to know this from the university. God knows what they come out with when they come out of the university. So if I talked about developers, let's talk about their tools. So one of the fondest memories I have, and try to get some memories for this talk, was in the 90s. I was working in Visual Studio 97, I think, something like that. And it would horribly crash if it had more than like 30 files or something like that. And that was the constraint. It was the A3 of software. okay? You can't use, your code needs to be compact enough because that's what you need. Today, you start a project, you get like 50 files just out of the box, okay? The tools support that. But that means that we have a lot of playground to add more and more software. So a constraint we had now is gone. The tools are becoming much, I talked about heavy machinery. They look like this, usually spread on a couple of monitors, okay? So, by the way, managers, team leads, this is why you're paying developers. You don't pay them to type. Developers operate heavy machinery. It requires skill, okay? Developing software is no longer just knowing a language. On the other hand, these tools are very complex because, yeah, they fit to the complexity. And the problem is that most developers don't really get to know all the options that are in there. So if you ask them about what kind of shortcuts they need or what kind of refactorings that the tools support, most of them cannot tell you because they are very busy writing their code that they need to do. So what can we do about tools? First, feed the tools to the job. I know it sounds very simple. It's true. Also in languages, but also in the tools themselves. We might need very big tools, we might need very small tools like sticky notes. Sticky notes, use sticky notes for not Jira. Learn the tools well. If you decided on using a tool, learn what it can do for you. Learn what it can do to you. I know about TFS. Use good practices. So good practices are very strange. I'm not using best practices because there are no best practices. Good practices are really strange because they may not be that good. They are simply working for a group of people. So, for example, Microsoft or HP or IBM or whatever, they have an IDE. They go to their customers and saying, oh, we want to develop the new feature. What do you need? And they tell them, well, we have these kind of problems. And they think, OK, would this work? And they say, OK, we can try it. So Microsoft or IBM, HP, or anyone else develops this product and this feature, give it to them, and they say, oh, we're happy. And the vendor says, it works for them. Maybe it will work for other people. So statistically, it works. But we're not talking statistics here. The tool may be good for other people, but it may not be good for you. So use good practices, but try and use your brains as well. Because if you pick the wrong process, you'll pay a lot more later with complexity. Of course, education is important. We need to learn and train people to just think about this stuff. Quality. Who has bugs in this building? 3 people. OK. Yeah, quality is a problem. Who works with Jira? It's a nice support group here. Yeah, so bugs are very interesting because we have testers. What happened? OK. We have bugs everywhere, apparently. Yeah, so we pay testers to test the system. So they test the system, and they report the bug. And then we say, OK, we can't fix it now. And then Jira comes in and says, I'll hold it for you. 30,000 bugs later, I can hold it for you because it's a very good tool. It doesn't crash after 30 bugs. And this costs us money. In bug reviews, I remember because I was a product manager, one of my one of the hats that I was wearing. And I had a weekly meeting about bugs, and I had to review the features, and I needed to prioritize the features against the bugs and the bugs against themselves. Most of the time, 95% of the time, most of the bugs got back into our system. I didn't have Jira. You don't want to know what I had. But yeah, it costs me time just reviewing and re-reviewing and not doing anything with these bugs except getting more angry that I have bugs in my system. And the list kept growing. What can we do? This week, in InfoQ magazine, InfoQ, the site, I'm not sure if Ben is not here yet. There was an article called Zero Bug Policy. It was written by someone who gave a session by this talk in our conference in Israel. The guy was an R&D manager, so we had a couple of groups under him, and he works in VMware, which is not a startup. And they actually managed to implement with his team Zero Bug Policy, which means either we fix it in the next 24 hours or we forget about it. Okay, sounds like black magic. But it works. 4 years ago, on my first Agile, Henrik Kniberg was here. He was talking about his project, and he inspired me to do something similar to what he did in the Swedish police, was having a backlog in my Excel of 30 things, features and bugs, and maintain this 30. Found a new bug, it had to replace another one. Actually scratch the information, the logs, and yeah, we will need it later, because nobody needs it later. It is possible, and it reduces complexity. It's very easy to compare 30 items to more than 300 and prioritize them. Of course, it needs education. Maybe you see a pattern here. Projects. Now we'll go back to the project managers. So projects are complex. And what time is it? Okay. Yeah. And they're like vacuums, they're like black holes. Because as they grow, they need more and more management. The project managers need more project management thing. But it's more than that. We were a startup, so we had one product. Now we have a program portfolio. And the level of knowledge within the different teams is different. Okay, so maybe we need to move people around, which is not always a bad idea, like Andrea. I'm really glad that Andrea gave this talk, because a lot of the examples actually talked about. So that's why it's weird to me to talk about all the scaling stuff, because it immensely creates more complexity, where basically we don't want it. And in order to compensate with that, we need more controlling mechanism. Okay, which again, a lot of people, a lot of meetings, a lot of reports that nobody reads. Some point, some nobody writes, but yeah. And there's one thing about as projects grow larger, what happens is that the Steve Austin effect takes place. Okay, it's hard to move forward, to invent stuff, disrupt. It's hard to do something without an approval from your manager. You need to go like up the pyramid and down the pyramid in order to talk to someone you have to integrate with. You have to look something very simple. Who is here in his Outlook or whatever calendar has triple booking? How does that happen? Okay, it's very simple, right? It's your time. You decide what to do. Nobody can go to three. I haven't met people who can go to 3 meetings at the same time. Okay? It's not possible. How come the software actually supports it? Okay? It's weird. It creates problems. So when things get slow, we lose our agility. And agility in the context of business. The ability to respond to market behavior, environment, and so on, in a way that is effective for our company. If we slow down, what do the project managers, apologies, will help us? So what can we do? Think small. This is a problem. This is a very big problem, thinking small, okay? But this is something that we need to do in order to reduce risk and complexity. If we're thinking about everything that we should do, it will take us 3 years. And we probably won't need everything that we should actually need. If we're developers and we're thinking about everything we need to develop just to make sure that this thing doesn't go wrong, it will take us these 3 years. It will create all kinds of bugs we need to fix later. We need to think small. Specifically, product owners with a big vision and the project managers. They have to drive, basically, you have to drive away your role. We're going back to experiments. We need to obviously create more and more experience as part of the work, but also in the way we work. So like Andreas said, something prescriptive, like you buy a process in a box, is by definition not agile. By making a project structure, we kind of constraining everyone in their own little boxes. Create small, durable teams. Small features teams, we talked about, Andrea had talked about the 70 people team, so obviously not. But durable, stable teams. Whenever we move people around, we're creating vortexes, the one with the sharks that I showed you before. And these vortexes are really rearranging the team. They need to learn about new people, how they react, what do they know, how they work, just complicating the system. Just by moving people around, we think about efficiency. Educate, 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 and part of the education is Evan's talks. Here's a talk about no project. Albina has the talk about no estimates. Learn about these things. They are very disruptive, I know, but they're simple to explain and very hard to implement, so they fit here. Risk. So how do we deal with risk, right? We know that the bigger they are, the harder it is to manage risk, right? And we want to try different things. But the problem with risk is that we sometimes ignore it. It will be okay. It's an Israeli thing, right? Yeah, it's okay. It's going to be okay. Or we say, that's a very good point. We need to address it, maybe in V2. Or we actually say, okay, this is the main risk. Let's spend the 6 months just on this to make sure that this doesn't happen. Okay? Yeah, so a few things to do this. First, visualize. I really like visualizing stuff. How we work, what are the risks, what are we working on, where are things blocking, where are blockers repeating. Visualize and you learn, and it will tell you what to do. Test early and often. Obviously, testing is nice. It will give you feedback, but I'm not just talking about the QA stuff or test automation, which is nice. Really like them. But you need feedback on what you're actually developing and the way you're developing. So test your processes as well, not just the products. And of course, we need to educate because these things do not just come out of thin air. So I know one person who actually can do this. He can go to 3 meetings at the same time. So yeah, he can do it. But it's really a mindset. Keeping things simple is a mindset. It's something that we continuously need to practice. To identify complexity, so this is too much, we need to work at it, and we need to give time to work on it. And we need to train people on it. Same things, identify and how to fix that. And identify new things that are traps for complexity. And Chuck Norris can do it. The question is, on Monday, when you get back to work, can you? Thank you very much.